Okay, so we've got a neglected large lawn, contains a certain type of weed. Alright, and the area of the lawn covered by the weed at time t years is W. The rate of increase of W is directly proportional to W. So it doesn't surprise me that it's increased because when there's weeds there, they just keep on increasing. Alright, so we've got here the rate of increase of W, how W increases over time, right? Okay, so that gradient function is going to be positive because we see that word increase here. And what's it proportional to? It's proportional to W, as it says there, right? So to get a differential equation, as it says in A, of course we've got that there, but of course we need to get an equation, we need to introduce equals, and of course to do that we introduce the constant of proportionality, which is K. And then we've got all these situations down here, yeah? So just as we usually do then, we're going to separate the variables to get an expression for W. So take that W over, so it'll be dW by W, K dt. So this time we've got W on the bottom, okay, so it's 1 over W, and we're back to the ln situation, okay, like earlier. And then K, when you integrate that, that'll be KT, yeah, plus C. Okay, so we've got that there. Now, we've got conditions here, so we'll use these, right? It would make sense if they give us conditions, just go for it straight away. You don't need to take like the ln over and E of that just yet, right? We could actually work out what my constant is from this here. So what does it say? The area of the lawn covered by the weed initially is 0.10 meters squared. Now initially means of course at the beginning, okay? So initially, okay, i.e. when t equals 0, yeah, that's initially at the beginning. The area, so W, remember, represents area, yeah, W is equal to 0.10, they say, right? That's why they've written it. So if we put it in here, ln 0.10 equals, well, t is 0, so that will go, so that's what C will be. So we have ln W equals to KT plus ln 0.10. Okay, and they want us to find, of course, an expression for W in terms of T. You might be thinking now, let's take things over the other side maybe, and work out then what W is. Let's do that, shall we? So if I take that over, I'll have ln W take away ln 0.10 equals to KT. Okay. So when I take it over, I've got minus logs here, because when you're taking away logs, the rule is then to divide them. Okay, you can write as a single log and divide. That's the laws of logs, right? Remember, ln is a logarithm. It's a natural logarithm. When you're taking away, you divide them. So that will equal to KT. And then, of course, to get rid of the ln, now we can take the ln over the other side and do the inverse of it, which becomes E. Okay, so W over 0.10, and that will equal to E to the KT. And of course then take that W up, so we get 0.10 e to the KT. Okay, so sorted, we've got the answer there. Now they give us a second sort of situation, and the second conditions, they say like 1 year later the area covered is 2.01. okay, so when t is 1, the W is, what was it again, 2.01. okay, so we could sub that into here, or we could even sub it into there, right? Or into here rather, to work out what K is. Okay, it's so I'll tell you how we go about this. Maybe we'll just sub it in here. Okay, so 2.01 equals to 0.10 e. Now t is 1, so 1 there, so that'll be k times 1, which is just k. Okay, so then sensible thing then to do is to take that over, 2.01 divided by 0.10, which is e to the k. So you might need to be able to work out in your head, or we'll just check on our calculator anyway. Okay, so of course that becomes 20.1. okay, e to the k, and then if we take the e over, we'll get the value for k here, right? So taking the e over, we'll get e over it, of course it becomes ln, isn't it, on that side, ln 20.1, which is what k is equal to. Okay, brilliant. So we can then put that into here, all right? So we want an expression for W, so if I write it over here, we could say then W equals to 0.10 E. The K then is ln 20.1. Of course, you're timesing it by T. Okay. Now, if I write T at the end here, it'll look a bit weird, won't it? Because it'll look as though it'll be ln 20.1 T. And I don't really want that. I want it to be like of ln 20.1 on its own times T. So maybe I'll write the T at the front. That would make sense. Okay, so I've got that. Now we can actually go a little bit further here, because if you notice here, right, because I'm timesing ln by the T, I can use the laws of logs again, right, and take that power T up there, if that makes sense. So I can say W equals to 0.10 E to the ln of 20.1. And you know, of course, because the times it by T, as I said in front, take it up, so it becomes the power T there. Okay, and then what I want you to realise is then, look what we've got here. We've got E to the ln. Okay, E to the ln. Now, because they're inverse functions, they'll sort of cancel each other out, won't they? Okay, they will cancel each other out because E to the ln. It's like squaring a square. It's like squaring a square root. Okay, or square rooting a square. They'll just cancel each other out. So they will cancel. So we'd just be left with this 20.1 to the power T. So W will be 0.10 times this 20.1 to the power T. And there's our expression for W.